Okay, for this question, for question 15, okay, what you can do, okay, is just to multiply in first. That's one of the tricks. When you see that sometimes brackets, right, you can't differentiate this to get this, right? So you can just multiply in to form different terms. Okay, so first you will get sine 2x cosine 6x minus sine 2x cosine power 4x dx. Okay, so let me just replace the cosine 6x and sine 2x. I like to put the bigger one in front. Okay, I'll put a 2 as well. So you can see this is actually the factor formula. Minus integrate. Now sine 2x I can change to 2 sine x cosine x. And then with the cosine power 4x. Now from here, we can actually do our factor formula. Okay, this will be under the second one, which is sine minus sine. So 2 cos 6x sine 2x, I will be left with sine 6 plus 2, 8x, minus sine 6 minus 2, 4x, minus 2 of integration sine x cosine power 5x. Now you can see from here, this is going to be a f prime x of cosine x. Okay, when you differentiate cosine x, you get negative sine x. So I can actually put a negative sign here, okay, turn that to positive, then put a negative sign here. So this is the f prime x of cosine x. So from here, I can just get half integrate sine 8x 1 over 8 cosine 8x with a negative sign. Then plus 1/4 cosine 4x. Okay, because you differentiate cosine x, you get negative sine x. Plus 2 cosine power 6x over 6. Don't forget your plus c. So now we just do negative 1 over 16 cosine, let me just change this, negative 1 over 16 of cosine 8x plus 1 over 8 of cosine 4x plus 1/3 cosine 6 power 6x plus c. Okay, this will be your final answer for part A. Now for part B, okay, let me just shift this diagram down. For part B, change to blue color. Okay, this is going to be an integration by parts question. Okay, so integrate of 2x plus 1 tangent inverse of 2x. Okay, I'll just put an equal sign the other side. So you can see from here that we are going to get our u as 2x plus 1. And so u should be tangent inverse 2x, mistake. Okay, this is based on LIATE. Okay, so your dv dx will choose from the bottom, and then your u will choose from the top, okay, in terms of ease of integration. So this is inverse trigo, which is under I. U will be equals to tangent inverse 2x. Okay, not easy to integrate, that's why we differentiate it. And dv dx will be 2x plus 1. So from here, we get our du dx equals to 1 over 1 plus 4x squared. Then differentiate the 2x to get 2. So it's 2 over 1 plus 4x squared. That's for du dx. And v, we can integrate this to get x squared plus x. Okay, x squared plus x. So we continue with the integration. So this will be equals to uv, which is x squared plus x of tangent inverse of 2x minus integrate of v du dx. So you get 2 of x squared plus x over 1 plus 4x squared. So x squared. So this one you bring down, copy down. Now this one is pretty straightforward. Okay. What happens is I can take negative 1/4. Negative half. I put a half outside, so I get 4x squared plus 4x. Okay. Over 1 plus 4x squared. So what I'm doing here is actually doing a quick uh division of the partial fractions. Okay, not really partial fractions, but just simplifying the fraction. Okay, so what I want to do here is to use the trick of plus 1 minus 1. So this adds 0 and it doesn't change the equation. Why we do that? Because 4x squared plus 1 divided by 1 plus 4x squared is going to be just 1. So x squared plus x tangent or inverse of 2x minus half integrate 4x squared plus 1, I put it as 1, plus, now I want this over this, 4x over 1 plus 4x squared. Why? Because I can see a f prime x over fx here. Minus 1 over 1 plus 4x squared. Okay. Pardon my handwriting. Okay, let me just shift the screen a little bit. So I'm left with, I can continue to bring down x squared plus x tangent inverse of 2x minus half x. So I want to integrate this first. Plus 1/4 integrate 8x over 1 plus 4x squared. Okay, 1/4 because 8x, I want to change 4x to 8x, and 8x is the differential of 4x squared. Minus 1/4 again, integrate 2 over 1 plus 4x squared. Okay, why? Because if you recall, what happens is that when we differentiate tangent inverse 2x here, we get 2 over 1 plus 4x squared. So now I'm going back by the reverse road. Okay. So finally, I'm left with x squared plus x. Okay, this one is going to be tangent inverse 2x. So you may want to combine this to this part later. Minus half x plus 1/4 ln 1 plus 4x squared minus 1/4 tangent inverse of 2x plus c. Okay. Plus c. Yeah. Okay. So just left with x squared plus x minus 1/4 tangent inverse of 2x, bracketed, minus half x plus 1/4 ln. Now, because this is always positive, we can choose to remove the modulus. Okay, you don't need to keep the modulus. Plus c. So this is the final answer. Okay. Now, for part C. For part C, we'll be using substitution. So this one question tests you on f prime x, fx, by parts, substitution. Okay, quite a number of things, but split into different parts. So remember, substitution, okay, there are always 4 things to change, especially if it's a definite integral. So this is a non-definite integral, there'll be 2 things to change, which is just the x and the dx. Okay, so the x usually, when we integrate, if you recall, we divide by d theta, then multiply by d theta. So we need to multiply by dx d theta, okay, so that it cancels out. The equation is still the same. So for x equals to for cosine theta, we need to first get our dx theta. Which will be negative 4 sine theta. Okay, so therefore, integration of square root 16 minus x square over x square dx. 16 minus x square. Now our x square is 4 cosine theta square will be 16 minus 16 cosine square theta. Okay, so I hope you can see that there's a 1 minus sine square theta here over 16 cosine square theta minus 4 sine theta d theta. Okay, so there is a 16 sine square theta here because 1 minus cosine square is sine square. Equals to, just shift this up, integration. This will become 4 sine theta, so I'm left with negative 16. Or there's a negative I brought outside here. So I'm left with 4 sine theta plus 4 sine theta. 16 sine square theta over 16 cosine square theta. Okay, the 16 cancels out. Tangent square. Okay, you can't integrate tangent square directly, so you always need to convert to secant square. Okay, tangent square theta, 1 plus tangent square theta is going to be secant square theta. So when you integrate secant square, it's just tangent. Okay, differentiate tangent is secant square. Negative tangent theta plus theta plus c. But don't end here. Okay, because this is an integration. It's not a definite integral. It's in terms of x, so we need to have our final answer in terms of x. But we get tangent theta. So how do we get tangent theta in terms of x? Theta is pretty simple. Okay, so we know that theta, x equals to 4 cosine theta, which means that cosine theta is equals to x over 4. Okay, so for this one, for theta, it's just cosine inverse x over 4. It's pretty simple. So what we can do, there are a few things we can do actually. Okay, we could either use the trigonometric identities or we can just draw a triangle. That's how we usually do it for E-maths. Theta, and if cosine is adjacent over hypotenuse, we can do this. So this one will be Pythagoras theorem 16 minus x squared. So our tangent theta is opposite over adjacent. Square root of 16 minus x squared over x. So the final answer will just be negative square root 16 minus x squared over x plus cosine inverse of x over 4 plus c. Final answer. Okay, just like this.